Right, when you have a word problem that talks about a rectangle piece of cardboard with a perimeter of 19 inches, 3 parallel and equally spaced creases are made, so cutting this rectangle into 3 pieces. The cardboard is then folded along the creases to make a rectangular box with open ends. Okay, so we're going to make a box that looks like this, figure 2. You're going to let x represent the distance in inches between the creases, and they want you to go ahead and use the graphing calculator to find the value of x that maximizes the volume enclosed by this space. Then give the maximum volume around your responses to 2 decimal places. Okay, now one of the things you want to do here is just, my figure is kind of close to that. You need to know the volume formula. That's basically length times width times height. So that's length times width times height. Okay, so we can see that length and width are both x. So we could go ahead and fill in part of that formula so far. Equals x times the height. Now we need to replace height with something that in terms of x. So probably has something to do with this perimeter information that was given to us. So that's what we're going to look at first. We're going to look at, let's write the perimeter. So each one of these pieces is x, so if you add them all together that gives you 4x. Okay. Plus 4x, so that's 8x's, plus twice the height. If you add all those together, that equals 19. Now what we're going to do is we're going to take this equation, we're going to solve it for h, so that we have an expression for h that has just x in it. So we're going to subtract 8x from both sides, and you're going to divide both sides by 2. Okay, so you're going to replace in your formula. So if you want, you could go ahead and multiply those together and say x squared, or you can leave them like this. It's really up to you. We'll just leave them since we're going to just plug that into the calculator. Now this is the volume formula. We only have x and v in our formula. The only thing we need to do is we're going to let v equal y, because in our equation when we're using a graphing calculator, there's not a v. We need to use x and y in our formula. So we're just going to say y equals x times the quantity of 19 minus 8x over 2. And then we go to the graphing calculator, and we need to plug this information in. So y equals, click on that, and say x. So if you want to just say x squared, I'm just going to do that. And then parenthesis, 19 minus 8x and you could do that a couple of different ways. You could just highlight the 19 minus 8x and divide all of that by 2, close parenthesis. Okay, so now that's our formula, right? Because x times x is x squared. So that's the same thing I just did here. Okay, so we've got that on there. Now what we need to do is we want to find the extrema. So we're going to click extrema. Okay, so we want to find the maximum. So we're going to end up hitting maximum, but we got bounds here. Now for the left bound, if we look at these values here, we know that x has to be greater than 0. And we also know that this height has to be greater than 0. So we're going to use the height as 19 minus 8x over 2 is greater than 0. So we need to solve both of these. Well, this one's already solved. That's going to be our left bound. And then go ahead and solve this. You're going to multiply both sides by 2, which just gives you 19 minus 8x is greater than 0. You're going to subtract 19 from both sides, and then you're going to divide both sides by negative 8. So that gives you x is less than 19 over 8. So remember, when you divide by a negative, you're going to flip the direction of the inequality. So 19 divided by 8 is 2.375. So this is going to be our right bound. I'm just going to put a box around this so we keep focused that that was what we used. Alright, so our left bound is 0 and our right bound is 2.375. Okay, and we want to find the maximum. So we click maximum, and we get our results here. The x coordinate is 1.5833. And asked to give the answers to the nearest 2 decimal places, so that's going to be 1.58. And the y, remember, y represents our volume, and our volume was 7.9387, so to the nearest second decimal place, so that 3 is going to round up to a 4, 7.94. And these were inches, so this would be inches cubed. And so that's what you would enter for the value of x that maximized the volume. That's 1.58 inches. And for the maximum volume, that would be 7.94 cubic inches. Now let's look at a couple of different variations. Well, one more particularly, and then we'll look at a third briefly. Okay, so for this problem, they're telling us that the manufacturer cuts squares from the corners of a rectangular piece of sheet metal that measures 3 centimeters by 7 centimeters. So 3 by 7. Here's this figure, a little more detail on this one. The manufacturer then folds the metal upwards to make an open-topped box, like figure 2. So x represents the side lengths in centimeters of the squares. Okay. So now we want to find the value of x that maximizes the volume. So what we need to do is we know that this, again, volume is length times width times height. Okay, and so here in this one we can say, hey, the height is x, so we're going to replace height with x. Now we need to come up with expressions for length and width that have x in them. Okay, so we know that this distance is 3, so we're looking at what this distance right here would be. So if we took 3 and we subtracted each of these little pieces x, that would give us that piece there. So this is going to be, this piece right here is going to be 3 minus 2x. And then this length down here, okay, this whole distance is 7, and we're subtracting these 2 pieces here, which are both length x. So you're taking away 2 pieces of length x. So that's going to be 7 minus 2x. So it doesn't matter which one you decide to make the length and which one is the width. We just need to multiply these two together. And then multiply it by the height. And that's our volume equation. So now we just need to plug this into our graphing calculator. Now remember, we're going to replace volume, or V. Let V equal Y. Okay? and plug that information in. And then we just repeat that process that we did previously. Click on our graphing calculator, click on y equals, we enter our equation, okay, so we have parenthesis 7 minus 2x, parenthesis 3 minus 2x, close parenthesis, times x. We click graph. We want to find the extrema, so we click extrema. Okay, now we have, we know that x has to be greater than 0. That's one of our, that's going to be our left bound. And our right bound, let's take the smallest side, 3 minus 2x, and that has to be greater than 0. And so if you solve this, you're going to subtract 3 from both sides and divide both sides by -2. You get x is less than 3/2, which is 1.5. Okay, so that's going to be our left boundary is 0 and our right boundary is 1.5. Alright, and then we are going to click on maximum. And so our x value is 0.65 centimeters to get our maximum volume, and the volume, which is represented by y, remember, is 6. We're going to have to round this. If you have 6.298, means we're going to round this 9 up to a 10, which makes this 6.30, and that's centimeters cubed. So this is the length we want to make the cutout pieces so that we get the maximum volume for this box. Now there's one other type of problem that you might get. It's very similar to the one we just did, except for you're going to be basically making a pizza box. Okay, so you'll end up folding this up and making it look like a pizza box. So when we're doing volume equals length times width times height, our picture is going to be very similar to this, except for it's coming back over and making a lid, basically. Okay, so we have this height again of x, so we can replace that with x. Now we just need to come up with the length and the width. So basically we're looking at, we need this distance here and this distance here. And so this side here is very similar to what we just did. Since this whole piece is 4 and you're taking away 2 x's, this is going to be 4 minus 2x. And then this piece right here, this one is going to be, this whole distance is 10. And if you take 10 and subtract 3x from that, it would give you the distance of these two pieces here. But we only want that length for one, so we just divide that in half. Okay, so basically you're going to have this equation, which is volume equals 10 minus 3x over 2, parenthesis, the width is 4 minus 2x, times the height, which is x. You're going to replace v with y, remember, and plug this into your graphing calculator. Using your restrictive values, remember x is going to be greater than 0, and then I always pick the smaller side. Take this 4 minus 2x greater than 0, solve this. This will give you your left and your right bounds. And then you're just plugging that into the calculator like we did for the other two problems.